My name is Dominic Preuss, and I'm here with Dave Nettleton, and we're going to be speaking about where to store your data on the Google Cloud Platform. So before we do any of the sessions, I'd like to set expectations. If this isn't what you're looking for, feel free to go find another session. I won't be offended. We're going to go through just a quick background of storage services to give you a little bit of context. We're going to go through some concrete examples of how customers use our products to give you a little bit of reference architecture for how our products are used together. One of the things that is always apparent to us is that you never use a single product. You're always using multiple products to make a solution. So it's useful to understand how we put these things together to build those solutions. And the last one is to give you a decision tree to help you decide which product to use. We spend lots of time explaining to customers the portfolio, and sometimes it's just really helpful to have a set of questions that'll get you to the right answer. So we provided a very high-level one to help direct you. Dave is going to start by going through some background.
Hi, everybody. Thank you, Dave Nettleton. So I've been working in the space of data and analytics for probably some 15 years now. So just wanted to walk you through a little bit of some of the changes in the use cases and the patterns and the technologies that we've seen in that time. And just use that as a way to sort of map to some of the technology that you see coming from GCP today. You know, I've used a slide like this in one form or another for the last, I guess, 5 or 10 years, and it constantly kind of blows my mind to see the kinds of things that customers are looking to do with data and the analytics that they can generate off that. And literally, you know, it's transforming industries in ways that perhaps people didn't even think about 5 or 10 years ago. I spent a lot of time talking with customers, and there's been this real change where technologies, new capabilities, and the cloud are really helping people think about how to not just run their industries more efficiently, but actually really disrupt them in very meaningful ways and create new businesses. One of my favorite examples is in the airline industry. So all those Rolls-Royce engines that you see on airlines as you're flying around the world and looking out the window and see the little RR letters, they're not actually owned by the airlines. They're actually leased to the airlines by Rolls-Royce. And you know, the reason for that is really interesting. Rolls-Royce realized that if they can manage all of the data and collect all the telemetry from those engines, do rich analytics on it, do machine learning on it, they can actually deliver a much better experience for their customers, the airlines, by ensuring that the engines are better maintained and that the airplanes themselves remain up in the air much longer. So they gather huge amounts of data, huge amounts of telemetry from these engines. They capture it, they run analytics on it, they do predictive maintenance on it. They don't, you know, strip engines down on regular schedules, go check them, and then put them all back together again. They're much more able to tell when they can need to bring an engine in for repair and maintenance. All sorts of industries are being transformed by this amazing ability to gather huge amounts of data and do analytics on it. So all industries, many use cases, amazing transformations happening. Let's talk a little bit, though, about what that actually means in reality when you're sort of, you know, feet in the ground, working in an enterprise, and thinking about, I've got some infrastructure, now I need to think about using the cloud to take advantage of some of the capabilities that it offers. And I sort of think of like, you know, 3 main stages of journeys that customers embark on. Sometimes they're doing these in parallel. The first was probably like 4 or 5 years ago where organizations were thinking, okay, I've got my on-premises infrastructure. What I'm going to do is I'm going to use the cloud for backup, for archival. I'll continue to use it through the application that I have today. I'm going to reduce my operational cost. I'm a bit worried about security. I'm a bit worried about networking. But yeah, I'll sort of dip my toe into the cloud and I'll start to archive and put some of my cold data up in the cloud. Or maybe I'm going to burst some of my compute into the cloud because I don't want to buy some new capital infrastructure. And so key areas of GCP that matter there are things like compute storage, networking. Security is very big, ensuring you have the networking capabilities to set up the security that you need between your on-premises infrastructure and the cloud. Sort of the second step in the journey is when organizations start to think about actually lifting and shifting significant parts of their infrastructure and running it in the cloud. So control is in the cloud. And here you're thinking about running much larger scale enterprise applications like scale-up databases, running them in VMs. You heard some of the great announcements this week about things like having HANA running now in GCP, and being able to just really lift and shift your infrastructure from on-premise to the cloud, and really start to think about the cloud as the primary place for running key parts of your infrastructure. Often that infrastructure might look still quite a lot like what you've been used to running on premises. It's just you choosing to run and operate it in a different way. Also here, you're starting to think about running much more compute in the cloud. A great example, I worked with a company that was doing, they wanted to do risk analysis for all of their trading analysis during the day. So they'd gather large amounts of data and telemetry from their financial traders. And for reporting purposes, they'd have to sort of understand the risk in their portfolio. So every evening, they'd run large amounts of compute over that data to understand their risk portfolio to report for compliance purposes. And they were literally faced with the choice of, should I buy a new physical data center and provision it with all the hardware that I need, or should I leverage the cloud for the large amount of burst compute that it can give me over that data? And as you start to move in this direction, you're starting to look for much more managed infrastructure. You don't want to be handling, managing 1 or 2 VMs. Okay, not too bad. Setting up clusters of thousands of VMs for either compute or for Hadoop is really not a business that you want to be in anymore. And so there's a set of managed capabilities that you see in GCP now that let you manage and operate large amounts of compute and analytics and data at scale. And then there's applications that are just getting built net new. So for cloud native companies, this is where they often start. They don't have any existing infrastructure, so they just start new. And you get new classes of applications here for like app dev, web, mobile, etc. But also new applications for data and analytics. And then you'll see a great set of capabilities here from like BigQuery, machine learning, App Engine to help you sort of build net new capabilities in the cloud. So these 2 slides just want to set up like a lot of use cases that we see that are very exciting to do in the cloud, and there's a lot of different journeys to get there. What I'll talk a little bit about now is a bit more of what's happened and what's been the evolution on the storage and the data side. So if we think a little bit about the evolution of storage, you start with the basic direct attached storage. So physical disks attached to a physical computer sitting under a desk, right? That's kind of the classic initial way that we bound compute storage and storage together. That has steadily evolved in enterprises now to bringing in SANs and NAS. And the key thing there is this observation that, hey, look, if we separate the compute from the storage with a network in between, then that gives us flexibility. We can better control how we provision our storage. We can better control how we provision our compute. We can set different policies on performance, etc. Let me ask, how many of you are today running SANs? All right, a handful. Okay. How many are you running NAS, so filers, shared filers in some way? Yep, okay, a few more hands there, right? So these are like core building blocks of enterprise infrastructure that people are used to using today. And if you look at what we have in GCP, we have a set of capabilities there to enable that. So if you're just running VMs with disks attached, then we have Google Compute Engine together with local SSD or persistent disk, which gives you a way to create a VM and attach effectively block storage to that. Local SSD is similar to DAS, where it's sort of local to the machine, whereas PD is more the data is coming over the network. How many people are running on-premise object stores? Wow, you got the whole lot, right? Yeah, so this is object storage is something that came about a little bit more recently. We don't actually see a lot of people running it because most people now do their object storage in the cloud. But this is also another way that people have chosen to store typically large, unstructured blobs of data. And we have a product, Google Cloud Storage, for that. So this has sort of been a little bit of the evolution of the kind of the core storage technology and the set of products that we have to sort of meet you where you are in evolving those technologies and applications to the cloud. Okay, let's switch over to databases and analytics. So, I used to work on a database product, a very popular database product, and I kind of joked to the very senior people who I worked with who helped create and build that product, man, you guys had it kind of easy, right? Because everybody knows what a traditional database is, right? So for 30, 40 years, the traditional database industry was kind of easy. You had a traditional database. You'd capture your transactional data against the database. If you wanted to do reporting on it, you would use ETL to extract data from the database, transform it, and then load it into a data warehouse. You knew the questions you wanted to answer, like, hey, what's the sales by region or sales by rep that I want to look at every week, right? So you knew that as you're pulling the data out, you could transform it into a different, Snowflake schema, whatever schema you chose, and then run your query and reporting against that on like a regularly scheduled monthly, weekly basis, right? And this was the world of data and analytics for 20, 30 years. The pattern was very, very well established. Everybody, who knows this pattern? All right, okay, most hands so far. Everyone, this is a really well established and well understood enterprise pattern. Oracle, IBM, Microsoft had great databases, also great data warehouses. Teradata and others provided that infrastructure. And then about 10 years ago, kind of all hell broke loose. There was so much innovation happening at the same time. So big data started to come along. Hadoop came along. The Hadoop vendors would say, throw away your data warehouse. You don't need it anymore. Put all your data into Hadoop. You need a place to capture gigantic amounts of unstructured data. Data warehouses are not cost effective for that. So where do you put it? So Hadoop was a great place to capture huge amounts of unstructured data. Then there's specialist forms of stores that started to emerge. Well, what happens if I don't have really structured data that I need to perform particular transactions on and I can make compromises? What happens if I want to capture really large amounts of data that I don't really know necessarily what the columns are that are going to be over time? Like IoT is a great scenario. Cell towers are always generating cell data records in terms of all the calls. Different versions of the software, different versions of the vendors, different versions of the software on the cell towers, all mean that there's no single well-formed piece of transactional data that's getting produced. It's becoming it's structured, but there's a lot of variation to that structure. So where do I store that data? Can I put it in a traditional database? No, that doesn't work. Can I put it into a warehouse? No, that doesn't work either. So you started to see a set of these sort of NoSQL stores start to emerge around two main patterns. One for very wide databases in terms of columns, and then another in terms of having much more sort of hierarchy and structure, typically for capturing things like JSON documents and other things that are very familiar for mobile applications. And then, at the far right there, so actually let me back up a sec. So this has caused, frankly, a lot of confusion, right? There's a lot of new technologies that are out there. There's a lot of people who are looking to learn a lot of new techniques and a lot of new patterns, not just running this in terms of infrastructure that they run themselves, but also in the cloud. And then at the sort of the far end of that, we just announced earlier this month Spanner. If you're wanting to run databases at really large scale, the only way you've been able to do that to date has just been to scale up. And up and up and up and buy bigger and bigger and bigger boxes. But with Spanner now, that's offering a really different paradigm to really give you a very effective way to scale out and actually get the scale and power of a really large-scale database with the simplicity of something like Spanner. And along the bottom then, we'll go through these in more detail. I put the set of Google products that are available in GCP that are the sort of the products that sort of help meet you on that journey. So actually, let's just get another show of hands. Who has a sort of traditional relational database in a VM? All right. How many people have data warehouses that they're dealing with? All right. How many people are using Hadoop and big data? Well, we've got everybody here today. How many people have used a wide column database in some shape or form? Okay. How about document stores? NoSQL stores. All right. Right. How many people have used Spanner? I know you're from Google, and who's that at the back? Great. Okay. So now we're going to dive in a little bit, and we'll go through each of these products in a little bit more detail and talk about some of the more specific use cases that we see for them. Okay. So let's start off first of all with storage. Google Cloud Storage is our managed object storage service. So this is for storing objects in the cloud. We offer it in four flavors: multi-regional, regional, Nearline, and Coldline. Each of those pretty closely aligns to key use cases that we see around content storage and delivery, analytics and ML, and archival. I'll go through those each in a little bit more detail. One of the things that we really love about this product is that we provide a very consistent API across all the different storage classes. So whether you want to archive your data or whether you want to serve it up from our most highly available storage class, you have the same API to access that data, and you get the same performance in terms of millisecond latency, time to first byte, and in terms of throughput. So this has actually let us do some really, and our customers do some really, really interesting and innovative things. And of course, we offer this with a very high availability. Let's go through one of those use cases in a little bit more detail. So content storage and delivery. And this is one area where Google has been very deeply invested for many years. As I'm sure you've heard, Google has several billion user products. Many of them require us to serve content to them really, really, really quickly. And so we have an amazing set of infrastructure in Google that lets us do that. And Google Cloud Storage is only one part of that. Google Cloud Storage sits on top of Google's world-class network infrastructure. And if you were at the keynote this morning, you heard Urs talk a little bit about that. We carry a very large portion of the world's network traffic on our network. And that lets us do amazing things like invest very deeply in really important high throughput connections, do really great traffic optimization, and serve data really, really well, and keep it on our network to the closest point to a customer. So this example, content storage and delivery, if you take somebody like, say, I'm a company that has media files, let's say, Vimeo, serves and delivers media content around the world, or you might have a website where you want to serve content, or you just have images that you need to serve as part of an application. So with Google Cloud Storage, you can store that data in object storage, and then tier that data based on how hot or not it is. So typically you might store this in something like multi-regional storage. This stores the data in two regions that are more than 100 miles apart. So if we happen to have a regional outage for some reason or other, data will still be served from within another region in that area. You don't need to change your application to fail over or anything like that. We handle it all transparently. And we'll serve content through directly from that. So multi-regional is a great storage class for that use case. If you find that your data is getting cold, media files are a great example, or movies. They get uploaded often. Maybe they get used for like a month or two and they're popular, but then maybe they don't get touched for a while. Well, when you're storing that data, that's still data that people might want to access, but you can't really take it offline and put it in like cheap storage that's slow to access. You still want to have that ability to access the data very quickly. With Google Cloud Storage, we let you tier that data through two storage classes called Nearline and Coldline that let you basically pay differently for how you access the data. So you might start out with the data in multi-regional, which is the most expensive, most highly available, but then as customers use the data less, you might tier it down to something like Coldline, where you pay much less for storing it, and the cost changes a little bit to pay for access. So it gives a lot of flexibility for how we do that. The other great thing that we do with Google Cloud Storage is that there's so much actually that's included just all as part of the product. It's kind of amazing. Data is edge cache. So if you store data in the US, but you consume it out of the UK, we carry that data on our network through to a POP that's as close to you as possible, often your ISP, and egress the data there. It's kind of like basic CDN functionality for edge caching. It's kind of built in, right? If you want to upload data, again, we don't upload over the public internet. We upload to our local POP and then take it from there. And then again, this consistent API and consistent performance, super valuable. No matter what tier of storage in, you get the same performance. The contract we want with your application is write your application and then manage your data differently. Your performance profile for your application won't change at all. So as well as using just GCS in its kind of raw form, we also have both a cloud CDN and great partnerships with other CDN providers. And these help you have more control over the caching policies for your data, where you peer your data, when it peers, and really sort of give you extra flexibility in how you build and deliver applications here. You saw this morning also, we have a great partnership with Firebase, one of our other teams here at Google, and making it really easy for you to leverage something like this for building mobile applications. Okay, so that's content storage and delivery for cloud storage. Okay, another use case for cloud storage. This is an analytics pipeline. So here, you might want to capture large amounts of data from a number of different sources for, say, marketing. Maybe you're an e-commerce site. You're capturing lots of data, log data potentially from your machines. It's capturing usage of what people have been doing. You might want to capture Facebook sentiment, Twitter feeds, etc. So you might have both data coming in real time, as well as data that you're pulling in occasionally in batch mode. And really, you want a single place to sort of drop all that data and often store it very cheaply. Maybe you're not quite sure what you want to do with the data yet in the future, and you just need some place to drop the data and store it for a long time. I worked with one company in the UK, very large e-commerce site. For 2 years, they spent 2 years capturing data, and they just dropped it into low-cost object storage. They weren't sure what they were going to do with it, but they knew they were going to need to capture that object, that raw data, so that they could do their analytics later. So if you think you're going to do analytics and ML at some point in the future, start thinking about gathering the data now. And a super easy place to drop and store that data is somewhere like GCS. Very cheap. You just pay for the storage as you use it. So something like the regional storage class, remember we have 4 storage classes, multi-regional, regional, Nearline, Coldline. The regional storage class is super interesting for this use case because what that does is it will effectively keep your data within a single region. And the reason that's often important in this use case is you want to spin up large amounts of analytics and compute to operate over that data. Now sure, you could store the data in multi-regional, but then you're going to pay a latency cost as we go access that data for you. So this lets you co-locate storage and analytics in a single region. And then with that, you can then start to spin up all of the other great analytics tools that we have in the GCP portfolio. So if you want to use Hadoop, take a look at something like Dataproc. With Dataproc, you can spin up a large Hadoop cluster, pay for it, and use it only for when you need it, bind it to the data that's in GCS, and when you're finished, shut it down. So that's great for doing batch analytics. Cloud Dataflow, super powerful set of tools and capabilities for running both streaming and batch analytics. Of course, you can use machine learning, point machine learning to this data. And then, the pattern that we often see here, and you might have heard the term data lake, is you use a data lake to kind of drop all of this raw data, and then you sort of transform the data and rewrite it back into the data lake, and you sort of do all of your batch pipelines and analytics on that data. And then when you've sort of come up with an interesting data set that you're ready to serve, often that's a great set of data then to take and put into something that's a much more structured store for analytics like BigQuery, right? So you might do lots of raw analytics on your data, establish some kind of batch processing, and then push that data into BigQuery for serving and accessing via your favorite BI tool of choice. So this, again, another very powerful pattern that we see. And the nice part about the cloud is we've done this really nice job of separating compute from storage. So you just pay for the storage that you need, pay for the compute and the analytics that you need, and build these very sophisticated pipelines. Okay, so if you're also thinking about, hey, what about all that data I've still got on premise? What am I going to do about that? How am I going to leverage the cloud for it, or how am I going to get it to the cloud? So we've got a set of interesting use cases and a set of partners that we work with closely here. If I want to ingest data, a set of partners to help ingest data, whether that be structured data or large-scale batch data, disk shipping, for example. We have a set of partners for that. Another use case we see is just doing backup and DR. So typically, you might be using an application like Veritas or storage use. It's an application that you're already familiar with. Cloudberry is something for the SMB market. It's an application that you're already familiar with, and under the covers, that will store data into something like Google Cloud Storage as the object store. Also, tiering, this is another super common use case we see. Folks have invested in some on-premises infrastructure, but they recognize they have cold data, and they don't want to pay for more infrastructure on-premises to store that cold data. So using something like NetApp or EMC, they're able to use the management tools that they're familiar with today and establish a cloud archival tier to store their data off in the cloud. So we've got a great set of partnerships with a range of companies here to let you use the tools that you're familiar with and still get the benefits of an on-premises environment that's bridged and hybrid across to the cloud. And I think that's me. Dominic, and we'll do Q&A at the end as well.
Yep. Our goal is to do about 40, 45 minutes of talking and then give time, sufficient time at the end for you guys to ask questions. So stepping over into the database world, I wanted to start by talking about Cloud SQL. So Cloud SQL is our managed service for third-party RDBMSs. So today, it supports MySQL. We are incredibly excited to announce Postgres support in Cloud SQL today, and we'll continue to add additional RDBMSs over time. So what this means is that it's a fully managed service that allows us to manage your instances on your behalf. So we're running MySQL, we're doing backups, we're doing security updates, updating the minor versions of the software so that you don't have to worry about that. We act as your DBA to manage that service for you. We do automatic backups and handle failover. So we maintain failover replicas. You, as the customer, have the option of running a single instance or adding a failover replica for your database. If you have a failover replica for your database and are running in high availability mode, then you have a 99.95% availability SLA. One of the things I do like to point out to people is that we at Google very much believe in putting numbers and guarantees behind our products. So you'll see as we go through this, all of our products have service level agreements that give you expectations of the availability that you'll get from that service. And it's something that we feel very strongly about. So what is a common use case and a common architecture for Cloud SQL? One is e-commerce. So in this particular scenario, you will have a e-commerce application. It might be running an app engine. It might be running on a compute engine. So this could be WordPress. It could be Drupal. You could be running Hybris. Any of one of your various e-commerce solutions that requires a MySQL or Postgres database. In the background, because we're running in high availability mode, we have a failover replica, which allows us to fail over in the event of a failure of the master node. We also have added read replicas. So one of the reasons to add read replicas to the architecture is you want to either shard your reads and writes. You might be getting close to the capacity that you can put through your master node. So you want to start sending your your reads to a read replica so that you get more capacity for writes on the master. Another very common reason to do this is your analytics workloads. So you don't want your analytics queries that are coming from your BI tool, whether it be Tableau, Looker, or iCharts, several of the partners that we have for Cloud SQL. You don't want the queries coming from those dashboards to interfere with your customer's experience. You don't want analytics queries to stack up and reduce the or increase the latency that your outside customers are. So quite often, people will set up a read replica and point their BI tools at this read replica to make sure that they've separated their analytics workloads and their production workloads. So that's a very common way that we see people using Cloud SQL. Obviously, with Postgres, it's very popular for mobile applications. So we're expecting to see an increased number of mobile applications running Postgres and using PostGIS as the Postgres feature rolls out. Next one is Cloud Datastore. So Cloud Datastore is our managed document database service. So if you are building a mobile or web app that is consuming and producing lots of JSON, or your data is in a document format, then Cloud Datastore is a fantastic solution for you. It's optimized for those mobile and web scenarios. It does auto scaling and auto replication. So you can start at 0, just start throwing data at it, and it will grow with your business. You only pay for what you use. So you pay for write ops and read ops and storage, and you don't pay for anything else. You don't have to worry about provisioning capacity up front. You don't have to worry about, am I going to have 10 users? Am I going to have 1,000 users? Am I going to have 10 million users? Am I going to become Snapchat? You don't have to worry about any of those things. You basically just start throwing data at Datastore, and it'll grow with your service. And again, going back to the service level agreements, it comes with a 99.95% availability. We do offer a regional version of this, which is not multi-region. So Cloud Data Store by default is multi-region. If you use our regional Cloud Data Store, then you'll get 3 nines of availability. Today, Cloud Data Store has lots of success stories in the mobile gaming space. You've heard many times about Pokemon Go. We've talked about Snapchat. But lots of mobile applications use Cloud Data Store as its application database. So you often have the application running. This could be the player front end that has all of the state about an individual player. All of that data is being stored in Cloud Data Store. On the back end, you've got your world view or the world data. So where are the players? What are they doing? What's going on in the world? All that information is running on a different compute stack. And again, all of that data is being stored in Cloud Data Store. You don't have multiple databases. You aren't running multiple instances. You're putting all of your data into a single data store, which simplifies your architecture and makes it easy to both deploy and scale up your application. On the front end, you're using Google Cloud Load Balancer. We don't talk about this as much as we probably should, but the Google Cloud Load Balancer is actually a fantastic product because it isn't a single VM being spun up in your project. It is a global load balancer that happens at the edge. And so what that means is that you don't have regional dependencies on your load balancer, and it allows you to load balance across regions. So in this particular scenario, this application might be a GKE cluster running in multiple regions, all speaking to the same Cloud Data Store backend. And you can load balance globally between those regions because the Google Cloud Load Balancer is a global service. We talked a little bit about Firebase. We're very excited to continue to leverage the amazing work that the Firebase team has done and to provide a first-rate mobile developer experience for Google Cloud Platform. If you're a mobile developer coming to Google Cloud Platform, Firebase is really that optimized experience for you to build your applications on top of. They do provide a real-time database option. So this is a managed mobile database service. The real strength of Firebase as a platform is the number of services that it provides, but also the native SDKs. So they provide an iOS SDK, an SDK for Android, an SDK for client-side JavaScript. So if you're building an application on multiple platforms, Firebase gives you a unified platform for building your applications. The other thing that's very important when we're building mobile is offline access. So if your customer is using your application and they are not connected to the internet, they might be in a tunnel, they might be in the subway, they might be in the middle of the woods in Yosemite, and they don't have internet access, you still have access to all of your database information because there's an offline version of the data. And then when that mobile device becomes back online, it handles synchronization to make sure that the data on the device is synced with the data that's in the cloud. So very powerful application from the Firebase folks. And again, the beauty of Firebase is because you're building on their SDKs, your architecture is very simple. You have a number of devices that have integrated their SDKs into your application, and it's all going to a centralized location in the back. A good example here is Firebase real-time database. Another good example is Firebase Analytics. You might be using Firebase Analytics integrated in all of your apps, and then it's very easy to export that data from Firebase Analytics into BigQuery so that you can run your ad hoc queries. So because we have this tight integration between Firebase, the Firebase services and the Google Cloud Platform services, it makes it very easy for you to leverage one, and then once you need to get the power of the Google Cloud Platform, it's trivial to move your data over and move it into some of the other Google Cloud Platform services. Next is Cloud Bigtable. So Cloud Bigtable is our managed analytics database service. So this is a managed wide column database service. We at Google are firmly committed to the idea of being the open cloud. One of the best examples of this is that we took our internal Bigtable technology and externalized it to the outside world as an HBase compatible client library. We wanted the outside world to be able to adopt the Bigtable technology in the easiest way possible with the least amount of friction. And we found that by giving them an HBase compatible client library, it allowed them to very seamlessly move their HBase clusters over and copy their data from one HBase cluster into ours. And therefore moving from a self-managed solution that could be running on-premise or on compute engine VMs onto a fully managed database service. The power of Cloud Bigtable is that it gives you very low latency reads and writes, so you get single millisecond reads and writes, and gives you very fast table scans, so that you can quickly scan through your data and pull out maybe the most recent version of a metric, or do these very large table scans. Currently, Cloud Bigtable is a zonal service, and so it offers you 99.5% availability for all of your data. A very common use case that we see for Cloud Bigtable is Internet of Things. So IoT, what we often see is that we have a number of devices generating information. From Dave's example earlier, it might be a Rolls-Royce engine developing telemetry, sending telemetry back to your centralized location. It might be sensors that are sending back sensor data. It might be mobile devices sending back event data or things that are happening on the device. Basically, you have a large number of devices generating a large number of pieces of data that all need to be pushed back into Google Cloud Platform to be analyzed, maybe today, maybe in the future, depending on what you're trying to do. So the way that we do this consolidation, and one of the best ways to get data into the Google Cloud Platform, is through PubSub. So Cloud PubSub is our message queue product. Similar to our load balancer, it is a global service. So if you have mobile devices or sensors or Rolls-Royce engines around the world that all need to be able to push back into a centralized location, Cloud PubSub gives you a global service to be able to push that data back. You don't have to worry that that device happens to be in Asia and your service is in the United States. You're just pushing it into Cloud PubSub, and you will enter the Google network at the closest possible location, and that data will be stored in Cloud PubSub. We then offer two different ways of getting the data out of Cloud PubSub, getting all those messages into your system. So Cloud Dataproc is our managed open source data processing platform that supports MapReduce and Spark. So if you have Spark jobs that you're running on-premise, you can put them into Cloud Dataproc. Same thing for MapReduce. You can do this in batch. You can also do stream with Spark, but most frequently we see batch. The other one is our fully managed data processing product, which is called Dataflow, which allows you to build on Apache Beam. So Dataflow is our data processing framework that we just pushed into the Apache project. It was recently accepted as a top-level Apache project called Apache Beam. And Apache Beam allows you to build these portable data processing pipelines, and is another very common use case. So once you have these data processing tools picking up the data out of PubSub, you're dropping them into Cloud Bigtable. So Cloud Bigtable then allows you to analyze the data. So it really excels at time series data. We use it quite a bit for graph use cases, and it is very efficient for writing lots and lots and lots of data and then doing scans across that data. It also provides mutations, so you can do ACID transactions at a row level if you need to do a large number of updates as well. And so until now, the way that people would analyze that data, they would go and run these queries. We're very excited as well to announce at this conference the ability for BigQuery federated queries to search Bigtable data. So what this means is you can write all of your data into Bigtable. So if you have a use case that requires a lot of mutations, or you need single millisecond reads and writes, where BigQuery doesn't meet that need and you need a database as opposed to a data warehouse, you can write all of that data into Cloud Bigtable, and now you can run your SQL queries from BigQuery using federated queries to query the data in line without copying it or ETLing it into BigQuery in Cloud Bigtable. So now we've provided a native SQL interface for doing SQL queries against your data in Cloud Bigtable. The added benefit of the Cloud Bigtable federated queries is that any of our BI tools, our business intelligence tools, or data visualization tools that are integrated with BigQuery now work on top of Bigtable as well. So if you are using Tableau, or Looker, or iCharts, or MicroStrategy, whatever your firm happens to be used, you now have compatibility with your data in Cloud Bigtable. Cloud Spanner. We were able to spend some time on it on the keynote today and really showed kind of the scale and the types of things you could do with Spanner. It is our managed relational database service. So it is a horizontally scalable relational database with global consistency and ACID transactions. And so what this means is that your data can grow with you. So if you happen to start on a smaller data set, and as you're growing over time, you don't have to worry about outgrowing your existing relational database. If you're currently running a sharded MySQL or managed or manually sharded Postgres implementation, then you know the pain that comes along with doing that, and Spanner starts to provide real value to you. Another example is high availability. So if you're running a master-slave scenario with any traditional RDBMS, you have to accept downtime on failover for things like software upgrades, security patches, maintenance. Because Spanner is distributed, we don't have to worry about that. You don't have downtime for upgrades. We can do all of the upgrades in line. You don't have downtime to do maintenance. Your service stays up and is serving your business. Because of this architecture and the fact that it's a fundamentally different approach to relational databases, we can offer 4 nines of availability for our regional instances. So that's 4 minutes and 23 seconds of downtime per month. And with the multi-regional versions that we'll be rolling out later this year, you'll get 5 nines of availability. That's 26 seconds of downtime a month. So how do people use Cloud Spanner? We've been running an early access program for over a year with a number of customers, and we've already started to see very strong adoption from the Cloud Spanner product in beta. One of the very common use cases is global supply chain. So places that you really care about global consistency are financial transactions, inventory management, places where being off by one really matters. Right? If you have 5 things and you try to sell 6 of them, then you have an unhappy customer, and that's a bad customer experience. And so Cloud Spanner provides you a consistent way of storing that data. So a common way that we see this is that in supply chain, basically Cloud Datastore acts as your ledger for all of your inventory. You might have an application which is your supply chain that is working with your various vendors that happen to be delivering pieces of your product and then going into assembly line. And then once those products have been produced, they go into a separate inventory system. So instead of having multiple data sources where you store your supply chain information and your inventory, you can store them all into a single database with a single source of truth so that you always have a global view of what's going on with your inventory and your supply chain. Another great thing about Cloud Spanner is that it's an application database that you can also do analytics on. And so you can connect your analytics queries to Cloud Spanner. It's a relational database running SQL. We've already announced a number of launch partners for data visualization and BI tools. We'll continue to roll those out through the rest of the year. But then you can also run your analytics queries on top of Cloud Spanner. And if you need additional capacity, you don't have to create a read replica. You just make sure that you're provisioned appropriately for your compute nodes to be able to handle that load. And BigQuery, so coming back, there's lots of sessions at the conference about BigQuery, but I want to touch on it briefly. Cloud BigQuery, or Google BigQuery, is our cloud-native data warehouse. It's a fully managed analytics data warehouse. It gives you tremendous speed. The thing that we often talk about is speed, which is that you can scan terabytes of data in seconds. We also talk about scale. Just like all of our serverless applications, you don't have to provision capacity up front. You don't have to say, I need a terabyte of storage. You say, I have data, here's my data, and now I'm going to start running some queries. There's very little upfront work that has to be done except defining a schema. You can start writing data in it, you don't have to provision it, and then you can just start running your ad hoc queries. And BigQuery, again, big on SLAs. BigQuery offers a 99.9% availability SLA. What is a common reference architecture? Kind of going back to our example before. Very similar architecture, writing a bunch of logs data into Cloud PubSub. So again, this might be mobile devices, it might be IoT devices, it might be applications that are generating events. All those events get written into Cloud PubSub. You process them with the data processing pipelines and drop them into BigQuery. Now, over time, you can go back and run historical queries. You can see how often are those events happening over time. You get auto date partitioning of your tables so that you can go back and run those queries in an efficient way. And again, because it uses that same SQL and you get that same interface, you get the same BI tools like Tableau, Looker, and iCharts. Great. So Dave and I have just gone through a large number of products. Hopefully, we have a managed service to meet every one of your use cases. Obviously, if there isn't one here, we have lots of tools to help you run your own workloads on Google Cloud Platform. But we want to make sure that we have at least a managed service for each of your workloads so that if you choose to go the managed service path, we have an option for you. So how do I decide? So here's a quick overview of all the things we've talked about today. We left out persistent disk, which we can talk about, which is our block storage device, and Firebase, because it's too big a slide. But effectively, this takes you through our options. So if you are looking for in-memory, we offer App Engine Memcache. So if you have an App Engine application that requires Memcache for caching, we provide that as a managed service. If you're looking for managed Cloud SQL, or managed MySQL, or managed Postgres, I'm so happy to be able to say that now. Managed Postgres, you have Cloud SQL for running your databases. If you outgrow what you can do in MySQL or Postgres, or need the super high availability that you can get from Cloud Spanner, then you can move up to Cloud Spanner as your scale out and highly available database for your mission critical applications. If you're building a mobile and web application and your data is document-based, then Cloud Datastore gives you a very easy onboard to grow from 0 to petabytes of scale with that data structure in a very easy way, in a very easy method for getting up and running. Cloud Bigtable is our analytics database, so if you have key value data or wide column data that requires lots of mutations, Cloud Bigtable. Cloud storage. Another use case that we don't really talk about, and why I always like to include it in the slide, is because BigQuery has federated queries, and the fact that BigQuery can search BigQuery columnar data, it can search G drive files, but it can also search GCS files. So another common pattern is customers writing Avro files into a GCS bucket and then running BigQuery to run their SQL queries all over that data. So unlike some of the other providers, we don't think that that's a separate product. We just think that that's a feature of BigQuery. And we see that pattern over and over again as a way for customers to maintain that data in a GCS bucket and to run those queries. So how do I decide? The magic slide, left it for the end. So people tell me time and time again, please, just tell me what product to use. So I've tried to take the last 2 years of advice and put it into a single flowchart. And what this flowchart says is, great, is your data structured? If the answer is no, then the next question is, do you need mobile SDKs? If you need a mobile SDK, then please use cloud storage for Firebase. If you don't need mobile SDKs, then you can use cloud storage directly. All the data goes into the same place. It's just 2 different ways of getting data into the system. If your data is structured, then the question is this an analytics workload? Are you trying to run analytics? Is the application latency sensitive? Are you going to run back over historical data? If the answer is yes, then the next question is, do you need updates or low latency? So BigQuery offers you mutations, but there's a limit as to how many you can do. So if you have to do a high volume of mutations or you need really low latency reads and writes, then you go to Cloud Bigtable. If you don't need either of those, then you can go to BigQuery. And BigQuery will provide you all of the analytics functions in SQL, historical, auto-partitioning, and all of the things that BigQuery does so amazingly well. So if you are not building an application, an analytics workload, so now you're in this main part here. So then the question is your data relational? If your data model is inherently non-relational, then the next question is, do you need mobile SDKs? If you need mobile SDKs and things like offline access, then you go to the Firebase real-time database. If you don't and you need client-side client libraries, then you go to Cloud Datastore. If your data is relational, and the answer is yes, then the next question is, do you need horizontal scalability? If you don't need horizontal scalability or the incredibly high availability that comes along with that, then Cloud SQL, either MySQL or Postgres, are going to give you the best experience for getting your application up and running. Incredibly strong ecosystem, tools that integrate with both, lots of community developer knowledge around it. And so it's a great solution for getting your application up and running. If you do need horizontal scalability, then you come to Cloud Spanner, and you can start looking at Cloud Spanner as your horizontally scalable relational database, so that you know that when you need the scale and when you need the high availability, it's there for you. So with that, Dave and I would like to open it up for questions. Last pitch beforehand, if you thought that this session was interesting, here's some other ones we highly recommend. Some of these are today and tomorrow. Some of them were yesterday. We are already posting many of the videos on YouTube, so I encourage you to go back and view some of the other videos offline if you want. But this is the selecting the right storage, or for GCS, selecting the right storage class for your use case, optimizing Cloud SQL performance, the Cloud Spanner 101 session, which was yesterday, but the video is already posted, and then 0 to app, live coding an app with Firebase and GCP. All related and also very good use cases.